Welcome back everyone, Mr. Allen here. Today we're going to use DESMOS to review the transformations we saw in grade 10 and kind of extend them into grade 11. So this is something you can do for yourself later on if ever you forget how things look. The key here is to recognize it's not up to you to necessarily remember what every graph you ever see looks like, but to understand what each individual addition to a graph will do. And if you don't remember, just kind of go into DESMOS and test it out. Basically play with some numbers and see what happens. So right here, I've got the y equals x squared, the sort of the parent function for the quadratics. And all we need to do is basically put in some numbers here and see kind of what change does that number make. So we're looking at this one here, and we see that the graph gets a little narrower. Here we get a graph, again, a little bit narrower yet. We zoom in a little bit on that. And so the key is sort of how much narrower does each of these get? And so what I'm looking at here is just, a vertical line saying, what is the value of y going to be as I make these changes to my graph? And so here we have the point 1, 1. On the blue graph, when we have a 2 out front, we have a point of 1, 2, so a y value of 2. And on the green graph here, we have a point of 1, 3, a y value of 3. If we change the location of that bar, so let's just move it along here a little bit, see if we can do 2. Similar idea. My original graph was at 2, 4. My blue graph now is at the point 2, 8. And my green graph, if I go all the way up here, is at the point 2, 12. So we sort of think about what's happened here. Given our original point being 2, 4, this point ends up being twice as high. This point ends up being 3 times as high. And of course, what we get is the number out in front here, what we normally refer to as the A value. That value determines how much stretch or compression there is in our graph. So I just kind of change this up a little bit, make it 0.5. You sort of see that the graph now is compressed. It's pushed down so that the point that was 2, 4 has been pressed down to the point 2, 2. The point that was here, the point that was 1, 1 is now pressed down to the point 1, 0.5. So it turns out that this number out front is basically taking the original y value. So if you look at this, it says that y is x squared. And so this is the original y value, and then multiplying it by the number out front. So now it's half as big as it was. Here it would be 3 times as big as it was. It's stretching the graph up by a factor equal to whatever this number is. Again, or compressing in this case. If the number is smaller than 1, it gets pushed down. If the number is bigger than 1, it gets stretched up. So really all I'm doing with this is looking at what the actual numbers do to my graph. Similarly here now, looking at another graph, x minus 2 squared. My original graph is the black one. My new graph is over here. And you can sort of see pretty clearly that this point has moved from 0, 0 to 2, 0. And we know from before that what that does is it gives me a shift to the right. Similarly here, my graph is going to be shifted to the left. This is the point -1, 0 now. This is the point 0, 0. Each point along this graph has been moved one spot to the left by doing this x plus 1 in my brackets. Now again, nothing here should be new at all, but just kind of a reminder. And then again, more importantly, understand that if you don't know how to do these questions, jump on DESMOS and change the numbers, play with the numbers, type in equations, look at them. Similarly here now, when I've got this number on the end, this plus 5, what does it do? Well, it looks like it took this graph and moved it up to this point here, so it moved it up 5 spots. What happens when I turn on this graph? -3, well, it looks like it goes down to -3. So this number on the end is basically moving my graph up or down by the value that's there. So those are kind of the first 3 key numbers. The number that's multiplied out front, essentially you're saying, multiply this number by whatever my y value was. So the y value becomes half as big, twice as big, 3 times as big. This number, maybe if I jump down here, this number down here says take the y value, again, y equals x squared is my original value, and then add 5 to it. So take whatever the y value was and increase it by 5, decrease it by 3. And so it moves the whole graph up and down. Those two numbers are pretty straightforward. This one we've seen before. Again, what you're suggesting is that to get to my original graph, or sorry, my new graph is this x minus 2. And so the number that I'm plugging into here for x has to give me the original 0 value. And so if I want to know what was going on here at 0, I'm plugging in the number 2. 2 minus 2 gets me that 0. I'm getting the same y values now in my calculation that I was on the original by having the whole thing shifted to the right.